All right, in this video, we're going over absolute value equations and inequalities. All right, here's your vocabulary. We got just two vocab words. We have number one, absolute value. The absolute value of a real number x, written, a little bar, x, and another little bar, is its distance from zero. I left out an S. Is its distance from zero on the number line. All right. And then extraneous solution is a solution derived from the original equation that is not a solution to the original equation. Sometimes you'll solve these out and stuff just doesn't make sense. Like you might get something like the absolute value of -7 equals -7. That doesn't make sense because absolute value will never equal a negative number. So that's an extraneous solution because it does not make sense. All right, it does not make sense. Now, to find your extraneous solutions, what you have to do is you have to solve and then plug your numbers back in for x and then solve the equation again and make sure everything is kosher. I'll show you what I mean by that. And then here's a couple concepts you need to know. Remember how I said it's the distance from zero on a number line? So the absolute value of x equals a. So the distance from x to zero is a unit. So you can go from 0 to the left and get the negative number, or from 0 to the right and get the positive number. The absolute value of x is less than a, or is less than or equal to a. I'll show you the difference between them two. So the top one is less than a. The distance from x to 0 is less than a units. So go to the left, a units, so you have negative. Go to the right, you have positive. Now, if there's no equal sign under here, you have open circles. You see how these are open circles? All right? If this had to been the absolute value is less than or equal to a, then what you would do is negative a, 0, a. Instead of an open circle, you're going to have a dot. Then you're going to shade everything between. So an open circle, you use an open circle when you have just greater than or less than. You use a dot when you have greater than or equal to or less than or equal to. So if you have the equal bar, you have a dot. If you don't have an equal bar, you have a circle. So this way, since the absolute value is less than, you shade everything in the middle. If it's greater than, you put your circles or dots, depending on if it's greater than or equal to. You put your circles and dots, and then you shade opposite directions. Okay, you shade opposite directions. All right, we'll go over that more as we go through the lesson. All right, let's look at a problem. Solving absolute value equations. So absolute value of 2x minus 1 equals 5. Now, when you're solving absolute value equations, you actually have two equations. Because think about it, this can equal -5 as well. So what you're doing is you're actually solving 2x minus 1 equals 5, and 2x minus 1 equals -5. So you have to solve both of these and you'll get two different x values. Now, this is your only different step from solving a regular equation, is you take your absolute value equation, get 2, but then you solve it the same way. Plus 1, 2x equals 6, divide 2, x equals 3. Add 1, 2x equals -4, divide 2, x equals -2. All right, now, what you want to do, you always want to check your solutions. So let's put the 3 back in. 2 times 3 minus 1, the absolute value of that should equal 5. Well, this is 6 minus 1. 6 minus 1 is 5. The absolute value of 5 is 5. Check, so x equals 3 checks out. Do the same thing for 2. Absolute value of 2 times -2 minus 1 should equal 5. Well, this here is -4 minus 1, that's -5. The absolute value of -5 equals 5, that's a check. So x equals -2 checks out. If, say this one here had come out to something, well actually, yeah, we checked it out. So say this came out to something different. It didn't come out, this didn't work. That means that x equals -2 would be an extraneous solution because it didn't work in your original equation. All right, that's how you check for extraneous solutions. All right, you always plug them back in and make sure it works. These two work, so therefore those two values are good. All right? All right, I want you to try one. Well, no, I'm going to show you this one first. 3x plus 2, that's absolute value, equals 4x plus 5. All right, now, we don't just have one thing over here. So what we're going to have to do is this. 3x plus 2 equals 4x plus 5. And then we're going to have to do 3x plus 2 equals negative 4x plus 5. All right, remember, so negative, and you put this in parentheses. So whatever the absolute value equals, you take the positive version and the negative version. So this one's going to be 3x plus 2 equals negative 4x minus 5 after you distribute the negative through. Now again, you solve them the same way. So what I want you to do now is go ahead and finish solving these and tell me what x equals. Pause the video. All right, hopefully for this side, you went negative 3. Now, if you didn't do this the exact same way, that's fine. So this is x equals, what is this, negative 3? All right, or, let's see, plus 4x, plus 4x, minus 2, minus 2. So what is that, 7x equals negative 7. So x equals negative 1. All right. Now, we need to check our solutions, so plug these back in. So we're going to have absolute value of 3 times negative 3 plus 2 equals 4, negative 3 plus 5. This here is negative 12 plus 5, negative 7. Can an absolute value ever equal a negative number? No, so we don't have to finish this, even though if you do, you get negative 9 plus 2, which is the absolute value of negative 7 equals negative 7. Does not work, does not work. This is an extraneous solution. You remember from the vocab? Extraneous solution, a solution derived from the original equation that is not a solution. Well, this is not a solution because the absolute value cannot equal a negative number. So this is an extraneous solution. Now, let's check this side, because if this is also extraneous, that means this is not solvable. All right, that means this has no solution if negative 1 does not work. So let's try it. 3, negative 1 plus 2 equals 4, negative 1 plus 5. Negative 4 plus 5, well, that's negative 1. That's positive 1, so it could work. Let's try this side. Negative 3 plus 2, absolute value of negative 1 equals 1. Checks out. Boom, x equals negative 1 is the only solution to this equation. All right, because the negative 3, we get the absolute value of negative 7 equals negative 7. That's not true because it's the distance from 0. So, and the distance from 0 is always positive. So this side didn't work, this side did. X equals negative 1. All right, that's how you do absolute value equations. Remember, you get two equations. You take your absolute value and set it equal to what's here. And that's what we did here. Then you take your absolute value and you set it to negative times all of this. So negative times the 4x plus 5. You solve both, you get two answers. Check them both, make sure they work. All right? Absolute value inequalities now. As you can imagine, work the same way. You have 2x minus 1. So you rewrite the same thing without the absolute value bars. All right. Then you write it, but now you flip your sign and make it equal to negative whatever this is. So 2x minus 1 is less than 5. 2x minus 1 is greater than negative 5. All right, so you're still going to have two inequalities, but remember, this one you flip the sign, and then, of course, you make it negative, just like when we did the equations. Just make sure. You should have one of each sign here. This one's less than, so you should have greater than over here. Now you just solve like you would any inequality. X is less than 3, plus 1, plus 1. 2x is greater than, what is that, negative 4, divide 2, divide 2. X is greater than negative 2. All right, so here, any number between, now we can actually write this as what I call a double inequality. It's actually a compound. Put your x in the middle. All right. Here, x is greater than, so x is greater than negative 2. If you read it that way, x is greater than negative 2, or x is less than 3. So you can write it this way, or you can write it this way. It means the same exact thing. Now, if we were to graph that, what would it look like? All right. Now, since we don't have equal signs here, we're going to have a circle at 2, a circle at 3, and since it's greater than negative 2 and less than 3, it's going to be all the values in between. It's going to be all the values in between. All right. If you can write it like this, your values will always be in between. All right. If they're both greater than or both less than, then you're going to have to do it differently. All right. Which the next problem that we're going to do is just that. All right. So last one. Absolute value of 2x plus 4 is greater than or equal to 6. What I want you to do is pause the video and solve the inequality and try to graph it. If you can't graph it, don't worry too much. I will show you what the graph looks like. So pause the video and solve this. All right, so 2x plus 4 less than or equal to 6. 2x plus 4, negative 6. All right, so minus 4, that's supposed to be a 4. 2x greater than or equal to 2, divide 2, x greater than or equal to 1. And then over here, minus 4, 2x less than or equal to negative 10, divide 2, x less than or equal to negative 5. All right, so that's what you should have got for your x's. All right. So now, if you look, x is greater than or equal to 1. So we know at 1 we're going to have a dot. And then x is less than or equal to negative 5. So we have the equal sign, we know we're going to have a dot. This is less than, so it's everything to the left. This is greater than, so it's everything to the right. So this is what you would look like. And don't forget to put your arrowheads on here. And then this would graph everything this way. So these are opposing. Okay, x is greater than or equal to 1, boom. X is less than or equal to negative 5, boom. Alrighty. And as you can see, you can't write this as x is as a number less than x less than a number, because if you did try to write it with x in the middle, you'd have greater than or equal to negative 5, then you'd have less than or equal to 1, and that's just not a good way to write it. Okay. Because if you look at this one, the difference is here. See, this one, your signs are going the same way. Negative 2, less than x, less than 3. But here, they're facing each other. Negative 5 is less than or equal to x, which is greater than or equal to 1. You don't want to write it this way. So if your signs face each other when you put x in the middle, well, don't write it like that, but then you shade to the outside. If your signs go the same way when you put x in the middle, you shade between them. All right? So that's it for solving inequalities. Make sure you understand the concepts, and see you tomorrow in class.